Here we have another related rates problem. It says a particle moves on the hyperbola. Hyperbola looks like this. X squared minus 18y squared equals 9 in such a way that its y coordinate increases at a constant rate of 9 units per second. How fast is its x coordinate changing when x equals 9? So let me rewrite this equation so you can see it better. It says x squared minus 18y squared equals 9. So it's saying its y coordinate increases at a constant rate of 9 units per second, which means dy dt equals 9u per second. It wants to know how fast the x coordinate is changing, so it wants to know dx dt when x equals 9. So for this problem, x would equal 9. So we can't quite solve it yet because we don't know y yet. And in order to solve this problem, we need to know y. So what we need to do is we need to take this value and just sub it in for x. So what that would look like is 9 squared minus 18y squared equals 9. So this would get you 81 minus 18y squared equals 9. You subtract 81 from each side, which I'm pretty sure gets you negative 72, equals negative 18y squared. You divide each side by negative 18, which would get you 4. Now you take the square root of each side, which gets you y equal to plus or minus 2. But in this equation, dy dt has to be greater than 0, which means we take the positive version. So y equals 2. So now we can solve. We have to take the derivative of this equation, which would be 2x dx dt minus 36y dy dt equals 0, because the derivative of a constant is just 0. So in case you didn't know what I just did there, I dropped the 2 down in front, left the x there, and because it's in terms of time, I put it dx over dt. Same thing for y. I multiplied the 18 by 2, which gave me 36, leave the y there, and then put it in respect to time. Now, I can divide everything by 2, which would get me x dx dt minus 18y dy dt equal 0. I'm going to finish up over here. I need to get dx dt by itself because that's what we need to find. So what I would do is I would add 18y dy dt over. So that would look something like this. X dx dt equals 18y dy dt. Then I would divide each side by x, isolating the dx dt. Now I can start plugging in my values that I have right here into what I have here. So dx dt would equal 18 times 2 times 9. And x equals 9. So before even multiplying this out, I can already cancel. And it leaves me with dx dt equals 36. But make sure you have units. So in this case, it would be units per second. And that's your final answer.